Okay, hopefully this is working this time because I just did the entire thing with it not recording. Okay, so we're looking at the three types of spectroscopy today. First one here will be absorption spectroscopy, and the device we're going to look at specifically is atomic absorption spectroscopy. So, our first element here, we have our sample. The sample will get drawn up through a capillary tube into a spray chamber where it will be mixed with our gas. That will travel through this system where it will get ignited in a flame burner. Down here we just have our waste where any liquid sample goes. So the main important thing about AAS is the use of this hollow cathode lamp. And so this is important because we are analyzing for a specific element, and each element has a specific cathode lamp that has to be used. So the element, the light is turned on, the cathode lamp is turned on, beam travels through the flame where it interacts with the calcium molecules, and some of that light is absorbed by the calcium. The rest of it will travel through into this machine, which is the monochromator. And this basically just gives us, it breaks down the wavelengths so we get the specific ones we want to analyze. After that, that light will travel into a detector, a photomultiplier tube in this case. That detector will change it into electrical signals, which will travel down into our readout here. So a computer screen in our regard. The next one we're going to look at is ICP OES. So this is our emission spectroscopy, and that stands for inductively coupled plasma optical emission spectroscopy. So in terms of how the sample is introduced, it's pretty similar. We have our sample tube here. It's going to go through a pump system, which is a little bit different, but it's basically the same. It's just trying to get it into our nebulizer. We're going to be mixing specifically with argon gas this time. That's going to go into the same machine here where it's mixed. We have our waste coming out, and it'll be nebulized, and the gas is going to come out from the top here. Now what's different is that we don't have a light system, so to speak. We don't have like a lamp that's shooting light into here. Instead, our plasma flame is going to be our light. And how we ignite it is we use an RF generator which sends particles in here. This will ignite the plasma, which has all of our elements in it. All the elements present in the sample will be ignited here, and that's one of the biggest differences, is that we can look at several elements at the same time. And so this plasma will emit light, and that's another big thing, looking at emission instead of absorption. That light will go into a monochromator just like before. Wavelengths will be specified to the ones we want to analyze, into a photomultiplier detector, and down to our readout where we can analyze the results. The last one we are going to look at is fluorescence spectroscopy. This is this machine here, and just looking at its schematic. So we have our light source. I'm not entirely sure if it needs to be specific or not, but the one that we're using in lab is a xenon lamp. So the light is going to come out of our light source. It's going to pass through a slit, so we're only a certain amount of light can get through. This is going to go into a specifically excitation monochromator, and this is just going to excite the light, and that excited light is going to go into our sample cuvette. So what's different about this one is that we're passing light directly through the sample fluid itself, rather than like burning it or turning it into flame or anything like that. And what this allows for, we have our full glass cuvette, is that some of this light is going to hit the sample and it's going to get transmitted through the sample. However, we're not analyzing that. What instead we're analyzing is the light that comes off at about a 90-degree angle to the sample. So some light will get transmitted. More light as well is going to get emitted at a 90-degree angle to the sample. That will pass through another slit and into our emission monochromator. And this emission monochromator will break down the wavelengths into the ones we want to analyze. And that will go into another detector, a photomultiplier tube, That signal was going to first go into a current voltage amplifier so that we have more of a readout to look at, and that is going to go into our screen and our readout where we can analyze the results. So those are the major differences between all three types of spectroscopy. They all use different machines. There are similarities in terms of like they're all using liquid samples, a big use of monochromators to analyze wavelengths, photomultipliers into a readout. But how the light is produced is all different, and what type of light is being analyzed is different between all three. So thank you for your time, and I will stop recording here.